So all of those transformations that we learned, that you go from left to right, when we are talking about, is there a reflection across the x-axis? Is there a vertical stretch factor? Is there a horizontal translation? Is there a vertical translation? That's where we're going with today's lesson. Okay, the first thing that we're going to do is we're going to take a look, we're going to just review exactly what I said. Given this function g at x, okay, this is your typical quadratic in vertex form. Okay, describe the transformations that have been applied to f at x if it was just x squared. How have we, so this was a question that was on your last, on your test, right? It had a couple more letters in it, and it said, you know, comparing A and P and Q and all that kind of stuff. But this, again, we just go from left to right. Is there a reflection that we have to talk about? No, because it's not negative, okay? So there's up to 4 things. 3 is okay if it's not negative. So just make sure that you guys are, okay, that you've finally figured out the language of this, right? So we want to see that this has a vertical stretch by a factor of 4, or sorry, of 2, by a factor of 2 from the x-axis. Okay, if you leave off from the x-axis, you'll lose marks for that. So like the whole thing's got to be there. Okay, then the next one, we look at the horizontal translation. So we have a horizontal translation. Whoops, let's spell that right. Okay, which way are we moving, left or right? Yep. Okay, if you want to say 1 unit, or you can just say right 1 or 1 to the right, that part, you've got some flexibility, okay? But you have to have horizontal translation, okay? And then your vertical translation, vertical, where are we at? Up 3. Okay, so, okay, we've been dealing with radicals. Now, we haven't really looked at what a radical function looks like yet. So today we're going to do the visual part. We're going to look at the radical function, what it looks like, and how it kind of compares to some of the other functions that we've looked at. So now that we've done all this, okay, given this new function, g at x, okay, the only thing that we've changed is instead of a quadratic, instead of an x squared, we're going to start with a radical. Okay, the exact same transformations that happen for the quadratics happen for the radicals. So this is still going to be, okay, if you want to write it out, you can. I know that I should, but I'm like a big old ditto, okay? This is still going to be a vertical stretch by a factor of 2. This is still going to be a horizontal translation to the right, 1 unit. And this is still going to be your vertical translation up 3. Okay, so the exact same transformations that happened before happen with our radical sign. Okay, so if you like thorough notes, you go ahead and write all 3 statements here again. Okay, so describe the relationship that we noticed. Okay, the parameters A, P, and Q from quadratic functions they are the same for radical functions. Okay, so it's just reminding you what those are. So that's our review of transformations. Okay, our stretch factor, our horizontal, and our vertical. Okay, and of course, because we're dealing with the radical, we will have a restriction. So what that ends up looking like is it ends up being a restriction in the domain. What we're going to do is I want you to pull out your graphing calculator because I want to take a look at what these functions, how they show up. Okay, so let's start with the basic. Okay, let's start with our very basic. We haven't done anything to it. What does a radical function look like? So head over to your calculator. Okay, you can clear out anything that you've been working on. Okay, and go for a, whoops, square root of x. No, I hit the wrong button. Okay, let me try again. Square root of x. There we go. Okay, I'm just going to zoom 6 so I have something that I can see. Okay, so some observations. Okay, it only exists on this half of the graph, which makes sense because what is the restriction on our function? Right? X has to be greater than or equal to 0. So that's what it literally looks like when x has to be greater than or equal to 0. Okay? It doesn't exist where x is negative. Okay? Now, if we wanted to do a table of values, okay, guys, you have two choices. Your table of values is here. Okay? You may either substitute. So when you put in x is equal to 0, you're going to get out 0. What is with my pen today? Okay, I erase this. Will it be nice? Yeah, there we go. Okay, so you can substitute. Square root of 1 is 1. I mean, these are easy numbers. Square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5. Okay, so then when we plot those, okay, then we're going to do 1, 1, okay, 4, 2, 9, 3, 16, 4, 25, 5. So you're going to notice that you have this nice shaped curve, okay, that keeps on going. Okay, that's what the traditional shape of a radical looks like. Okay, just like when we started with quadratics and we learned that it was the shape of a parabola. And then we started moving the parabola and stretching it. We're going to do the same thing here. Okay. Now, I'm just going to tell you, because you probably already know, if you ever needed to check your table of values, don't forget in your calculator, you can just do second graph, which is your table of values. So you'll notice that you get errors for anything that is less than 0, right? Because there's a restriction in the domain. And then you'll notice that, okay, you get nice numbers, but then you get decimals, right? Because it's taking the square root of 2, the square root of 3. So you might have to hunt for some nice numbers to plot, right, until you get to 9, and then you'd have to go to the next one at 16. So it's kind of easier just to pick the numbers yourself so that they fit nicely into the table of values. You can always check with your table of values on your calculator if you need to. Okay, so go ahead and, okay, as you can see, we've just shifted the numbers over by 2 so that when we substitute, okay, so here, what's our restriction? Our restriction is x minus 2 has to be greater than or equal to 2, which means that x has to be greater than, excuse me, or equal to 2. So you can see that we're taking our original function and we're just moving it 2 units to the right. Okay, so if I substitute in 2 minus 2, square root of that is 0. 3 minus 2 is 1, square root of that is 1. 6 minus 2, 4. Okay, you see what's going on here. So this time we're going to start at 2, 0, and then we're going to do 3, 1, 6, 2, 11, 3, 18, 4, and 27. Wow. Hello. No worries. Oh, I forgot. Part of the question said, state the domain and range. Okay. So our range, okay, I guess I'll write the word in. Our domain, let's start with that one. Usually we go domain. So x such that x has to be greater than or equal to 0. Beyond that, x belongs to real numbers. Okay, so there is a restriction in the domain. Is there a restriction in y? Can y be negative? No. Okay, so y, there is a restriction in the range as well. Okay, y such that y is greater than or equal to 0. Okay, so because there's a restriction in x, and then due to the nature of the question, there's also a restriction in our range. Okay, so now we've just shifted over 2 units. Okay, and that affects our restriction, which affects our domain. Okay, so the domain here is x such that x has to be greater than or equal to 2. That x belongs to real numbers. And our range is the same as before. Y such that y has to be greater than or equal to 0. Okay, in the next question, part C, do you see the difference between B and C? So in B, the number is under the radical sign. That indicates that there's a horizontal translation. In C, the number is outside of the radical sign. So that's your vertical translation. Okay, that's just taking our original function and we're just going to move it down 3 units. Okay, so again, we're taking the square root of 0 and then we're subtracting 3. So we end up with -3. Okay, 1 minus 3. Okay, -2, got -1, 0, 1, and 2. Okay, so we are down here, 0, -3, 1, -2, 4, -1, 9, and 0. Okay, 25 and 2, 25. Oops, sorry, 16 and 1, 25 and 2. Okay, so the shape hasn't changed. We've just been moving it along. Okay, the x-axis and the y-axis. You can take a look at that. Okay, go ahead and write in the domain x such that we're back to our original restriction. X has to be greater than or equal to 0. Okay, and now our range. Okay, our range shifts because we now have that vertical translation 3 units down, so our range can be a little bit lower. Y has to be greater than or equal to -3. All right. Make sure I don't change it before you've written it all down. So what I would like for you to do is start working on example 2, explain how to transform the graph to your original function, your original radical, just the square root of x, to obtain the graph of each function. State the domain and range. Okay, so you're just going through your 4 transformations and writing down the ones that are applicable. Okay, if you want to do a little sketch, awesome, because that I find that helps with stating the domain and range. Okay, so if you feel like you've got this, I'll let you work at your own pace, and then I'll just kind of summarize on the board. Okay, here's your check-in. So you should have, a vertical stretch. okay, by a factor of 7 from the x-axis. Okay, and then there's also a horizontal translation, right 9 units. Okay, if we were to do like a quick little sketch of this, okay, this would be like my regular function there. It kind of looks like that. If I did a stretch, it would still be here at 0, 0, but it would like, you know, pull up, right? You're stretching it. And then if I did the horizontal translation right, it would like be something like this. Okay, so for me, visually, it helps to kind of see my domain and range if I did a little sketch. You don't have to, but if you are visual and you find that that helps, okay, you could do that. So your domain should be x such that x is greater than or equal to 9. Okay, so this right here determines your domain. Okay, and the range is x such that x, sorry, let's try y. Y such that y is greater than or equal to 0. Okay, and that gets affected by the vertical translation, of which we don't have any, so it stays at 0. All right, keep going. All right, I'm ready for B. Okay, B, we had a reflection across the x-axis. Okay, there's no stretch factor, there's no horizontal translation, but there is a vertical translation. Okay, 8 up. So again, if I were to draw my regular, this is what it would look like when it's reflected across the x-axis. It just gets mirrored, okay, underneath the x-axis, and then we have to move it up 8. Okay, so then our domain, okay, x such that x is greater than or equal to 0. Okay, and our range is y such that y, now it has to be less than or equal to positive 8. Okay, did you get that? When you have a reflection, it flips your range. Now your range has to be less than. Okay, because we're now facing downward. Okay, and we're getting into some of the negative y values starting from that intercept, starting from that y-intercept. Okay, C puts all 4 together with not a lot of room, so see if you can ram and cram and jam in all your words in part C. All right, so when we take a look at this, we have a reflection across the x-axis. Just a reminder, because there's a couple people want to make sure that you clean up your, like once you say that there's a reflection, that kind of like uses up the negative sign. Okay, the negative has been taken care of. So when you have a vertical stretch, make sure it's just the absolute value of whatever that was. So it's a vertical stretch by a factor of 2, not by negative 2. Okay, the negative is the reflection piece. So now the stretch factor is just the 2. Okay, we had a horizontal translation, left 1 unit, and a vertical translation of 3 units down. Okay, if I were to draw that, so in my mind, I'm kind of picturing I have my regular, now I'm reflecting it, so it's going down. I move it 1 to the left, okay, and 3 down. So I'm kind of like over here. Okay, so this point here is at -1, -3. Okay, so then my domain, so my domain is affected by the radicand, x such that x has to be greater than or equal to -1. Okay, and my range is affected by my vertical translation. Okay, and because there's a reflection, okay, instead of usually it going has to be greater than, okay, we end up having to say has to be less than y such that y has to be less than or equal to that -3. Right, are we all good on domain and range? Okay, it seems to be people's kind of, let's say, least favorite thing to do. Okay, we introduced it in grade 10, you get it again in grade 11, you for sure get it in grade 12, and in calculus. Domain and range are incredibly important. So if you're hoping that maybe it'll go away, it's not gonna go away. Okay. All right, write an equation of the radical function that results in applying each of the set of transformations. Okay, so now we're just translating words into math. Okay, vertical stretch by factor of 4. Looks like a 4. Okay, then a horizontal translation, 6 units left. Okay, so that looks like horizontal translation happens under the radical sign. Left, 6 units. Right, so go ahead and do the next two. All right, vertical stretch by a factor of 3. Horizontal translation, 2 units right. And a vertical translation, 4 units up. Okay. See, reflection across the y-axis. That's your negative. Horizontal translation, 1 unit left. And then a vertical translation, 3 units down. All right. Okay. For the next one, we have just a couple more examples, and then we'll get you guys doing a little bit of questions on your own. Okay. Given the radical function, state the domain and range. Okay. In order to be able to state the domain and range, you want the radical function to be in standard form. Okay. That means y on one side, because it's a function, everything else on the other. So the only thing that you need to do with this is just move 2 to the other side. Okay, so that we have y is equal to negative x plus 1, okay, plus 2. So now, okay, so whether you draw it or can just visualize it in your head, okay, domain and range. So the domain is set by the restrictions of the radicand. So we have x such that x is greater than or equal to -1. Okay, and our range. Okay, if you weren't sure, could you graph this on your graphing calculator and at least see it? Absolutely. Okay. And y, sorry, so it's a reflection. So y is going to be less than or equal to, okay, the vertical translation. All right, example 5, which function has a domain where x has to be greater than 5? So we're looking for something, okay, if it's greater than +5, okay, we're looking for something like that with the domain and a range. If it has to be greater than or equal to 0, that means that, okay, because it's greater than, that means that there's no reflection. And because it's 0, there's no vertical or translation. So we're looking at A. Okay, so just make sure that you can kind of see the difference between all 4 options. Okay, hopefully the distractors weren't very distracting for you. All right. All right, now it's your turn. Okay, you have a whole bunch of functions here. Go ahead and write the domain and range for all of them. Okay, and then you just have some practice questions on the back page where you get to draw it, write down the transformations, state the domain and range. Okay, our quiz that's coming up on Thursday, okay, will include everything that, like, we're finished the radical unit now. Okay, and this, guys, this was your bonus lesson. Okay, this gives you, so you'll get that little bit of that head start because the regular 20-1s, they won't see radical transformations until 30-1. Okay, but you guys are seeing it now, okay, so that you're just that much more ready for 30-1 AP. Okay, so they can kind of pick up and continue on. So we'll have a variety of questions from adding, subtracting, multiplying, dividing, rationalizing, radical equations, and radical transformations, which means that, okay, the second part of this unit, we tie radicals together with trigonometry. So that means trigonometry starts tomorrow. Okay, and we're all excited for that. Okay, I've gone ahead and filled it all out. Okay, so no surprises with our linear line. There's no restrictions on the linear line. X and Y both belong to real numbers. Okay, when we square it, right, we lose all of our negative Y values. So Y is greater than or equal to 0. Okay, here's our radical that we've been learning about. So there's a restriction that X has to be greater than or equal to 0, and same with Y. Now this one's interesting because don't forget, when the square root is under the radical sign, there's no restrictions. Okay, so X can belong to real numbers. There's no restrictions on the X. However, the Y, I think the Y though is still going to be positive. Okay, because if we put in -2, then we square it, we get 4, and then we take the square root of it, and we're back to 2, but now it's a positive 2. Okay, so that's why this one is greater than or equal to 0. Okay, when we put the squared on the outside, okay, we're back to having the restrictions under the radicand. Okay, so the X has to be greater than or equal to 0. Okay, and then when we have our horizontal translation, that affects our domain, does not affect our range. Okay, when we put in a vertical translation, right, that's where it affects our range. And then if we put a reflection in, okay, the reflection also adjusts the range. So just make sure that that last one, okay, the sign is different than all the other ones because of the reflection. Okay. If you have any questions, you can come up and see me. And then, of course, you guys are working on this one. Okay, for the original one, okay, you can say like original function, or you can even say at the origin if you're just wondering, because there are no transformations that have been done on the original one. So, okay, at the origin, no transformations.